Welcome back, everybody. I hope you had a good break. We were just discussing during the break how complex this subject is. So I'm really looking forward to this discussion on a very multifaceted topic of resilience. And we are joined by two more speakers. So we'll be joined by Dr. Long Seng To, who is a Royal Academy of Engineering for Development Research Fellow, lecturer in resilient energy systems and co-director of STEER at Loughborough University. We are also joined by Dr. Elena Firstman, Vice President and Head of Global AI Accelerator at Ericsson. So before we kick off with the discussion with all of our speakers, I'm going to invite the two who have just joined us to give us their 3 or 4 minute perspective on our theme. So let's start with Long Seng, please.
Great, thanks a lot, and really enjoyed the presentations. So my take on resilience is really from the angle of energy. So my research looks at the challenge of providing affordable, reliable, sustainable and modern energy for all. So that's Sustainable Development Goal 7, in the context of increasing shocks and stresses, things like climate change, disasters and conflicts. And my work focuses on how to enhance community energy resilience using renewable energy, mostly in South Asia, Sub-Saharan Africa, and the Pacific. So what I found is that communities are really proactive in ensuring or gaining access to energy services. For example, in Nepal, after the Gorkha earthquake in 2015, households in rural areas were able to repair some of their own renewable energy systems, and some energy user groups connected to the grid were able to make repairs to a local energy distribution system on their electricity. So I think that engineering solutions should really be based on the observation of what communities' own energy resilience strategies are. And here I think there's a real role for collaboration with social scientists who have tools on creating that understanding of the key challenges and responses of communities, and of course engineers who have a good understanding of the solution space. It's also really vital to link policy actions at the international level, like we saw at COP26 recently, with the realities on the ground. For the Pacific Island countries, for example, they've just launched the Framework for Energy Security and Resilience in the Pacific, which is their energy policy until 2030. And it's being followed by discussions with countries, utilities, and communities on how to really achieve those goals.
Thank you so much for that. Let's go to Elena, please.
Thank you so much. And I'm kind of representing the digital infrastructure industry here in this forum. And I'm also a part-time researcher and adjunct professor in cyber-physical systems. So these past 18 months have taught us a number of things, obviously, about vulnerabilities that we have in society. And I will take a technological perspective to all of it, because I'm kind of a technology person. So first of all, of course, we looked at different types of tooling and collaboration and innovation. What did go well, and what were what parts of the innovation system were suffering, really? We learned that actually for the first time with COVID, when we were all in lockdown in a global big industrial company, that our innovation actually increased, which was a very interesting finding. I think what we understood is that this digital infrastructure has helped the diversity and the researchers and engineers to actually get together in a completely different way. So before we were more siloed when we were, for example, running innovation workshops together, when it was, for example, people in Sweden only and in some other countries only meeting face to face. Now instead we could actually mix and create a lot of innovations. Then, of course, digital connectivity is a very, very important enabler in all of that. We learned that quite a bit. The networks become even more critical. The quality of service became even more critical. Not only we want to support the kind of the big innovation in the society, but of course we know that there are a lot of critical use cases. So, for example, when we're talking about remote surgery, we are talking about operating heavy machinery, remote controlled, and so on. So these need to give priority. So there needs to be some kind of quality of service guarantees that need to be there in the infrastructure. When it comes to kind of networks and IT, of course, security aspects are extremely important, because when the digital infrastructure goes down, then we're kind of incapable of collaborating in the same way. So I think the policies and the proposals for policies, for example, EU's regulation on trustworthy artificial intelligence is extremely important for us, for the industries to adhere to, where we have the safety aspects for the remote robotics, where we have the accountability aspects for the algorithms, because this is a backbone for us to be able to collaborate in a very efficient way. Thank you.
Thank you, Elena, for that. We've got one question from the audience in, but please do keep them coming in. So this one is for Roger about your Tesla self-driving example and how that prompts an obvious question for AI. Is perfection the enemy of the good? You could postulate that an autonomous car could kill only 10% of people that drivers kill, but would that be acceptable?
This is quite difficult. Many years ago, I was engineering manager of a group that built the initial Docklands Light Railway, and we accidentally, under manual control, ran a train off the end of the track. It was on the front page of the London local paper, and everybody said how appalling. This is a computer controlled thing. We mustn't have computer controlled equipment around here. It wasn't actually under computer control, it was actually under manual control. But the general view of the press and the population was that because the term computer appeared in it somewhere, it was expected to be perfect. If we'd said, look, this is just another old train, sorry, some guy got it wrong and ran off the end of the track, no one would have worried at all. But I think there is a very different attitude to what counts as acceptable if it's managed by AI, compared with what counts as acceptable if it's managed by people. And that is not, I'm not a sociologist, but I think this is one of the questions where engineers have to work very closely with sociologists to understand why people have this particular view. So I think that's an important issue. Another serious problem, I think, with autonomous vehicles is that the way that you regulate other transport systems, particularly the computer systems on them, is basically to do an absolutely rigorous what comes in, what goes out, how does it all work type of testing. You can't do that with an AI system. A human makes a mistake, comes up to a roundabout, looks both ways, messes up, drives onto the roundabout, hits somebody. Everybody just says, oh, just made a mistake. So everybody could do that. If a computer did that, completely unacceptable. You wouldn't analyze it. You would have a load of data. You wouldn't know what to do with the data. And certainly, I just don't see how the normal methods that we use for assessment of software are going to work if you have AI on highly technical subjects and subjects that are basically safety critical. So perhaps not answering the right question, but I think it's an important issue.
And would anyone else like to come in on that one? Or I will, yeah.
Well, just a short comment. I fully agree. It's we expect everything to be perfect with computers, and if I would have the opportunity, I would actually recommend a book called written by Cathy O'Neill, I think the name is. It's The Weapon of Math Destruction. that actually tells about how easily these AI system can get biased if you're not careful. Thank you.
Thank you. Next question is kind of related. How can we engage the public with questions of resilience and security without causing panic or concern? Who would like to kick off on that one? Any thoughts? Yes. Go on, sorry. Anne-Marie, do you want to go?
Well, with my former employee, we had a motto, which is, or a vision, which is everybody. We want everybody to be able to dare and to have the knowledge to use the internet. And I think we need to have more knowledge among every internet user. You can't expect them to know exactly what will happen. You need to educate on the wide and in depth with engineers, and to make sure that everybody have the right skills and competence to do what is expected from them, or at least to make an informed decision on whether you should do things or not.
Thank you. Carsten, did you want to come in?
Yeah, I just think that dialogue here is a very important tool. We need to simply explain as much as we can, and it's almost a never-ending communication task. I think so much is happening out there. And for instance, me personally, I'm at a technical university. We need our researchers to go out and explain what it is things are doing, and also being honest about it, honest about the challenges, positive sides, but also the negatives. But unfortunately, sometimes the negatives steal the headlines. But I believe actually that most people can see, if you explain it in a proper manner, can see that it has benefits to them. And I think that a lot of people don't realize how much technology is actually part of their day-to-day lives, and how much they can actually relate to it if proper explained. But it's a humongous communication task.
Thank you. And Elena, I think you had your hand up there.
Yes, I would like to comment really shortly. I think it's a bit of a generation thing. I think we will see it pass by. So we are obviously in a transition period, how much we can trust systems. If you look at, for example, natural language processing algorithms, there is a threshold after which it is really, really good. So you can distinguish. I think the new generation, if you look at the new generations, they are very critical. They have this critical thinking. So when there is something written on the web, for example, they won't trust just a term. They would rather, analyze it if there is a critical mass and so on, compared to other generations that would probably, just read something and believe in it. So I think the acceptance will come just because of these numbers. I mean, if we go to Tesla example, obviously the numbers talked for themselves. And then, all these examples with saying you have an automated thing, but in practice there is a human doing the task. We will see the reverse things. Maybe there will be humans fronting an automated thing and saying, this is a human, but in practice it's AI that's actioning. So that will help the acceptance in the society.
And Roger, did you want to come back in?
Yes, thank you. One of the points that Carsten said was that researchers had to go and explain to people what it was they were doing and why it was a good idea. I suggest really we should go a lot earlier, that people don't want someone to come and explain to them and tell them that technology is good. It's a question of consulting with the population beforehand, so that we're actually developing what's being asked for, as opposed to developing it and then saying, right, we will have a government information programme to say why this is a good thing. And that to me feels like a really important shift in the way in which we discuss technology with individuals and with society as a whole, rather than making it something that we basically do as an elite and then put onto them.
Carsten,
I think that's a very good point. My message was merely that as individual researchers, there's a lot to do, which can actually make a huge difference. That one's put yourself out there and explain. We also have the opposite, that nobody really wants to take part of the debate because I get misunderstood and what have you. So for that reason, I think it's very important that those who know about it, even in these times of fake news and everything, not as a government program, but as a normal thing, that they participate. I really think that can make a huge difference in the way we attract this. And just one thing which I never thought was going to happen, but just a reflection. If you look at the GDPR rules, I mean, most companies have seen them as a pain in something, and now I think even the public realizes that maybe there's some good in that. That the fact that we are seen as digital individuals with rights and things like that, it actually changes a little bit how we see things, and that was certainly not the case when we started off with GDPR.
Thank you. I'm going to move on to another question. I think we're quite good at building resilience with hindsight after something has happened. Do you think we're getting any better at building that resilience in earlier? And maybe I'll go to Longsang if you could talk about some of the examples that you mentioned in the beginning.
Yeah, I certainly hope so. I hope that we are getting better at building in resilience in the preparation stage, right? So especially that's important in developing countries where, there's going to be need for massive investment in energy systems in those countries. So if we can locate them in the right places, do some modeling to look at what the effects of climate change are going to be, co-design solutions with communities, as it's just as important for energy access as it is for some of the technologies that we've been discussing.
Thank you. Does anyone else want to comment on that? Yes. Go for it, Roger.
Thank you. I think it's very easy in the energy field to come up with solutions, or part solutions. We will build, I don't know, 20 gigawatts worth of extra wind turbines offshore. We'll build so many of these of such and such. I think where all this falls down is in how you put this lot together into a system, how you bring together the control systems for charging your electric car at night, the control systems for operating your heat pump to warm the house, the control systems that take from wind turbines, from solar panels, from everywhere else, the information that says this is what's available, this is how best to manage it. And I think looking at energy as a system is something that we're actually only just approaching the foothills. We're nowhere near the situation where we can confidently go ahead and say, this is something we've solved, or we're well on the way to solving.
Thank you. Anyone else want to come in on that, or I can bring in the next question?
Well, actually, I was thinking that, it is so important in the context where I work, in the Pacific Islands and developing countries where supply chains can be quite long. So it is really important to have the local expertise and the capacity to make repairs when systems fail. And that can be more important, I'm sad to say, for us engineers. It can be more important than gold plating a system and making it robust in that sense. The ability to repair something is more important. So if the parts are available locally, even if it's more low tech, can be more resilient.
Thank you. I'm going to take this question's for Carsten. Do you think the 7 learnings from leading technology regions apply equally to organizations, and where all capabilities are not available. How do we enable successful collaboration?
Thank you very much for that question. Of course, there's a lot organization can take from those. These recommendations or findings which we saw was ecosystems where we saw that the actors commonly shared this perspective, and sharing also means that people can organize themselves and organize in what the sequence of actions is very good. But I also think that a lot of these regions that we looked at, they are really good at looking outside their own region and how things are evolving, and they are very good at teaming up with others from whom they can learn. And for that reason, they have a vast network of networks which they use for their companies, their governments, their local governments. They are sort of how do you say, active, very active, and share this full picture. And of course, this also counts for organizations. So the only thing I can say is that in the old days, we all wanted control over everything, and this has changed dramatically. You need to work together with people where you don't have full control of what they offer or how you do it, but you can set a framework in which you have a shared understanding, and hence you have a much higher sort of chance of executing. And if you do it right, there's a lot of value to be created.
Thank you, Carsten. I want to talk a bit more about the digital world and touch on some of the points that you made, Anne-Marie. You talked about rebuilding trust. How do we do that in a digital environment?
Well, first of all, by trying to avoid accidents. And with that said, I think that is, of course, not possible to completely avoid it, but we need to bring in security from the beginning. Most of the time, innovators and people who are inventing new things, they are more interested in getting ready to launch than they are by making a secure product. So there is something that engineers need to learn. I know that system developers, for instance, that is examined from the university, at least here in Sweden, now they don't get very much of cybersecurity or how to develop secure systems in their education at all, which means that when they're finished and starting to work with companies, they are potential risk themselves, which is something that we need to avoid, actually.
And Elena, I don't know if you want to add anything to that from your point of view.
I was thinking about an example from Ericsson where, we have our field services, which is quite a big part of the organization that's supporting all the digital infrastructure out there in the field. And that's a very, safety critical job when you send a truck with people and they climb the base stations and they climb on the antennas and repair. So I think it's super critical to. So these are typical tasks that we want to automate, obviously, and solutions that are sending, for example, drones or robotics are very important there with the computer vision and so on. But I can also absolutely agree with Anne-Marie here, because if we don't consider security and ethical and trustworthiness of algorithms as a hygiene factor when we develop algorithms, then we fail big time, because we will be building in vulnerabilities in our systems.
Thank you. We've got a comment from one of our audience members who says we use assessment and look at potential scenario. We use risk assessment and look at potential scenarios and check. If we do that for human systems, we should for AI systems as well. After all, you can simulate. So I guess, is there a risk assessment process when it comes to building some of these AI systems? Anne-Marie, I think yes. You're nodding there. Oh, yeah, go on, Elena.
I'm sorry, Elena.
Well, I was about to say yes, absolutely. So all these policies and frameworks, they are there. And I mean, security for a usual software, that's a slightly easier task to test a piece of software. For AI is a different type of task, obviously, to make sure that algorithms adhere to all these trustworthiness principles. And that book that Anne-Marie was referring to, Weapons of Math Destruction, I love that one. That talks quite a bit about, bias and discrimination, how algorithms can accidentally become like that. So methods exist, and I think we need to use them as a hygiene factor to assess the risks and actually to test if the parts of the system that are running on AI are resilient or not.
And if I may add to that, that is why you need to have diverse groups that do this risk assessment. You can't just put together a team of engineers because they are like-minded and they think almost the same way. So you have to bring in legal people, customers, anything. You have a different kind of mix here where you can do this risk assessment and think about what is the worst thing that can happen and how do you prevent that.
Thank you. Roger, during your talk, you made a point about conflicting objectives of complex systems, and I wanted to pick up on that with all of you, I guess. So that comes into everything that all of you do, and how do you manage those conflicting objectives of the complex worlds that you are working within? Maybe we could start with you, Roger.
Yes, I mean, in the complex systems project that the Academy is running with Lloyd's Register, we looked at quite a number of places where things have gone wrong, because that's really quite a good way of ensuring they don't go wrong again. And in many of these cases, we found that there were quite serious conflicts of interest, particularly at the senior management level, where one part of the organisation wants maximum diversity of suppliers, so ensuring that we have large numbers of competing groups working in an area. Engineers, on the other hand, say, well, the obvious thing to do is to appoint a systems architect who then runs all this lot together and produces one group, probably more expensive, without all the competition that the former group wants. So even within a project team, there's conflict between those that are, for example, looking at the commercial viability of the project and those that are looking at the technical viability of the project. Once you move out of that area into the more serious area of politics, of national policies, you get exactly the same sort of project, same sort of problems. What would make sense from a technical engineering point of view quite often doesn't really make much sense if you've viewed it from a political viewpoint, which has a whole load of totally different objectives. And I think from the analysis we've done, if you look at failed projects, most of them fail because nobody has really set out in detail what the project is trying to do. They will say, we want a new computer system to run National Health Service or whatever. They don't go into the thousands of pages and definitions of exactly what that computer system has to do, how it will work in the event of part of it being attacked by a cyber threat, for example, how it will work if you lose electricity, what happens as a fallback option when that stops working. Just a good example, during the Storm Desmond in 2015, Lancaster lost its electricity supply. The substation was flooded. People were amazed by quite what happened when you lost your substation. You lost the electricity for about 100,000 people. Even things like your garage door, you say, I'll take my car out, but it's an electrical garage door. How do you override it? You go to the petrol station to buy fuel. Petrol pumps run on electricity. You worry, as has been talked about earlier today, about your mobile phone. OK, I charge my mobile phone, still doesn't work. The base station shuts down. Take all these together, people were completely amazed by quite how interconnected everything was, and they hadn't thought it through. And this, I think, is one of the areas where, in terms of actually writing the specification of what we're trying to do and thinking of the failure modes before it happens, is actually very important.
Thank you, Roger. Anne-Marie, do you want to go next?
Yes, I absolutely agree with Roger here. And we have been talking in the Swedish Royal Engineering Academy about aggregated risks, meaning that more and more people and organizations are using the same technique. I mean, we once built, for instance, internet to be redundant, resilient, diverse, and it's always working. But now we are centralizing all the services into a few companies that we all are using, a few algorithms for encryption that we all are using, a few support programs that we all are using, which means that if any of these get any problems, we all are in deep problems, which is the aggregation of risk. And nobody, I would say, have the overview of that risk today.
Thank you. And yeah, on anyone else have any views on how you manage conflicting objectives? Yes. Sorry, I've had a brain freeze. Long-Teng, please go.
No worries. I've got actually two different points of view. So let's go with the micro point of view. So looking at communities, I think it's really important not to idealize the word communities. I mean, it's made up of different people, and it has an existing set of hierarchies and power relationships. And I think it's really important when talking about things like co-designing with people and users of technologies, when we do these kinds of participatory actions, to be really aware of those existing inequalities and not to replicate them in the new development of new technologies. From the macro point of view, I've just really enjoyed this discussion today because for energy, I think there are three main trends that will really affect energy security and energy resilience, certainly in electricity. One of them is climate change. I've spoken about that already. The second is the response to that, so more and more renewable energy being added to the grid. But the third is actually cybersecurity and how to manage our energy networks reliably. So I've learned so much today from you guys.
Thank you, Long-Teng. Does anyone else want to comment on this subject? Yes, Elena?
Thank you so much. I think it's the world is full of conflicting objectives, and if we just go back to the UN Sustainable Development Goals, the set of goals that are, in essence, they are grouped as societal, environmental, and business goals. These three blocks of goals are conflicting. So often we have, for example, security versus productivity versus environment. They all three conflicting. I think it's very important for us to be clear on kind of to be realistic, because I mean, from technology perspective, that's a multi-objective optimization. So in the end, we'll have some kind of digitalized version of these goals, and then we have some kind of Pareto optimal solution or set of solutions. But then in this Pareto optimal set of solutions, I think the decision makers need to be very clear and also realistic on what kind of goals we are setting here. So, for example, when we are putting environmental thresholds, they need to be realistic so that we don't sacrifice productivity completely. Because if we are, for example, talking about companies producing vaccine against diabetes, for example, that is about human lives. So we cannot put too hard constraints on environmental parameters of that factors, for example, because this lives of people we are talking about. So yeah, realistic thresholds for sure.
Thank you. I will move on to another audience question. What do you think about explainable AI? Can bringing out mechanistic understanding of what the AI develops, such that how it works can be more explainable, and will that help get user acceptance? So I think I'll go to Anne-Marie probably for this one, if that's okay.
Oh, thank you. That's an easy one. Well, I would really like to hear someone who make AI understandable to everybody. It's quite complex, and there's no AI without data. And we are talking about big data where we collect a lot of information. A lot of people are now afraid that their privacy is going down the loo, or that they are watched over by governments or by big companies, and we need all this data to make all these services that actually we will benefit from, and trying to explain how this plays together and the usefulness of it, because it's not all bad, of course not. It's a lot of useful services that will come from this development, but we still need to find a way to tell this so easy as possible to the public. Yes, but I'm not the one to respond to that.
Thank you, Elena.
Yes, so I think it's a super interesting ethical question about explainable AI. So there are methods out there. So these methods will essentially show you which parameters affected the algorithm solution, and very often the algorithms. If we would, for example, pick an unfair algorithm that was trained on unfair data, the explainable AI in the end will pinpoint exactly what are the reasons of discriminating, for example, certain people, or all these algorithms about filtering out. Screening the CVs when applicants apply to jobs. Then there are some screening algorithms that if they train on unfair data, then you will have an unfair algorithm, and then this explainability can tell you, well, that's because of this and that. Are we ready for that? I think that's a super interesting behavioral question, because these biases, they are kind of built into the world. They're always a bias in the world, obviously. So I think it's really, really important to put them out. To actually explain them, and to explain, and then the same goes for all these self-driving cars, for example. In the end, some engineer will have to encode some kind of ethical algorithm, and then the algorithm will follow that. Are we as a society ready to understand this system of preferences that is being encoded? Technically, absolutely possible. Behavioral science, I don't know how society is possible to accept it or not.
Thank you, Elena. I've got a question for Long Seng. You mentioned not replicating existing inequalities when engaging with communities. How can we best ensure that inequalities are not replicated when collaborating on an international level? What do you see as the key components of a successful collaboration?
Yeah, I've thought about this a lot as well. And all of the answers require time and funding to make a reality, I would say. It takes time to build up trust and collaboration, for people to find voice within a partnership, to learn what each partner can bring, and then to set up partnerships that are of equal contribution and benefit. And I think there needs to be a base level of funding for that kind of networking, partnership building activity. So I don't think we can shy away from that.
Thank you. We've got a minute and a half left, so I've got a final question for all of you. At the start of the session, we asked the audience who they thought had the most important skills for managing complex systems, and they said engineers. Do you agree, or do you have a different view to this? And I will go to Carsten first, please.
Well, I think engineers are hugely important to the transitions we need to go through. I think the discipline of engineering might be more important, namely, how is it that we design our solutions so they actually solve issues and problems that we really have? And engineering, it's much more about what the engineers do. It's also about how we work together with other disciplines in order to get the right solutions. So that would be my answer.
Thank you. And let's go to Roger.
I think there are different types of engineer. I've come across far too many people who say, I'm an engineer, I'm a real expert in the stress analysis of turbine blade roots or something. And frankly, that doesn't get you anywhere. There isn't a mechanism in engineering, an understanding in engineering that people have about how you put together systems. And I think when we come to talking about training engineers, it's essential that we actually develop that. Yes, we have got this skill, but I wouldn't suggest it's widespread.
Thank you. And Anne-Marie, what do you think?
I think engineers are important, of course, but I think there need to be a mix of people who know about human behavior, people who know about ethical and philosophy, people who know about economics and finance. I still think that we need a lot of different skills and experiences here to make this right from the beginning.
Thanks. And Longseng, can we go to you next?
I'm also going to vote for interdisciplinary work. I think it's so important in the work that I do to really have impact, and certainly for achieving the Sustainable Development Goals as a whole. If we look at all the different targets, we can see that achieving one of them, so for example SDG 7, requires action on a range of number of other Sustainable Development Goals, and vice versa. To achieve one, you need to take action on the other ones.
I agree also. So let's go to Elena for the final answer.
Engineers are very important for sure, but engineers are, in essence, very good at building a solution given the boundary conditions. And the boundary conditions, or a task, an objective function, and actually what does it mean? What does it mean to make a solution that would work perfectly in a society? And that boundary condition and the task as such will come from all the other like behavioral science, societal science, and everything. So that is extremely important. So I second that.
Thank you very much. I think we will close the discussion here. So thank you so much to all of the panelists again for this. I think it's just highlighted how complex and interconnected the world that we live in is. And I would also like to thank all of the speakers again that we had across both of our sessions today, and of course for you all for your questions and your engagement, which have brought out some interesting points throughout the day. This closes our engineering content for the day, but please do join us again this evening at 5 p.m. UK time or 6 p.m. Central European time for our social event. We are going to have some outstanding entertainment for you from Joe Stilgo, who is an internationally acclaimed singer, pianist and songwriter. And there will also be time for you to meet other attendees and reflect on the content that we've discussed today. You can join us by rejoining this live stream page and scroll all the way down beyond the Q&A section, where you'll find a link to click to join the evening session. We're also back tomorrow, so we will be back at 10 a.m. UK time, 11 a.m. Central European time for our final session of the conference, which will focus on the social implications of our technologies and explore how engineers can help build a more inclusive future. So I hope you enjoy this evening, and I look forward to seeing you tomorrow morning.